Okay, so what have we got here? This 22-inch television is something I bought possibly 10 years ago from, I think I got it from one of the big supermarkets. It might have been Tesco's. And it was only ever supposed to be like something quick and cheap and easy, because I was working away from home quite a lot of the time and I wanted something all in one bundle. And this TV did Freeview. It's got a DVD player in the back of it, and it had VGA input and HDMI input, so I'd be able to plug my computer into it, watch DVDs on it, watch TV on it, and plug my PC into it. And it meant that I just had one display solution for everything, which made it easy. Well, it's also the biggest screen I've got at the minute, and that's what I've been using for my computer for years, and I've gotten away with it just fine, no problem whatsoever, never given me any trouble. Recently it started making a weird buzzing noise. I'll just put a sample of that on for you now. Okay, so I've got my little microphone that I made, and I'm just going to hold it up to the speaker and you'll hear this noise that I'm talking about. Yeah, oh dear. Well, this looks like a job for somebody else. Okay, so as I'm sure you can hear, it sounds a bit poorly, doesn't it? I think it might be an idea if I take it apart and have a look, because I have a funny feeling something's not quite right. Let's go. Okay, so what we've got here is pretty basic and pretty run-of-the-mill. We've got what they do is they've got an off-the-shelf TV tuner card. This is basically the entire television. You've got an RF section here. I don't actually know what these accessory card sections are for. I don't know whether or not it's memory or what. I've never actually played with one of these, so you know, if anybody knows what these card sockets are that are on all the tuner cards, I mean, I guess I could have looked it up before I recorded the video, but if anybody knows, just leave it in the comments. There's a few inputs and outputs. It depends on the topography of the board as to how it's all laid out and everything. We've got the VGA input, the USB and HDMI, bit of a heatsink for the main graphics chip, blah blah blah. It's all pretty boring and normal. There's some video output to the actual screen itself. The screen is an off-the-shelf component. In the centre there's the power supply. It's a little switch mode power supply, and back here we've got the DVD player. This is all the disc mechanism, reader head underneath here. Sorry, on here, with all the circuitry underneath here. And then we've got the supply for the screen itself, the actual power supply to fire up the lighting. So that's all there is to it really. There's a couple of little speakers down here, and that's where the noise is coming from, but that's not the problem. And I can see what the problem is already. Let's take a closer look. Okay, so this capacitor just here isn't looking too healthy, to be honest with you. Okay, and these two capacitors here are looking a little bit bulged also. It's really difficult to get the camera in here close enough. I can see it with my eye, but I can't quite get the level with the camera. Believe me, they're toast. So, you know what might make an interesting test? Something we haven't done for a while. You guessed it, I'm going to break out the Rigol.
A few moments later.
Okay, so this is the test setup, and I've got my multimeter here. It's a half decent multimeter, and I've got my oscilloscope. I've got the oscilloscope on the output of this power supply just here, and the power supply doesn't have a load at the minute because I have removed the output. And as you can see, we're getting all this, well, this doesn't look much like DC, does it? So, I mean, let's have a look here. Okay, peak to peak voltage, let's have a look. 35.4 volts from just there to there. That's not particularly good DC, is it, when the difference between the lowest point and the highest point is 35 volts. So, you know, you can see that that's not a healthy DC output. So I'll bring you in a little bit closer, and I'll show you a little bit more about what I'm doing. Okay, so we've got the output is just along here at the very edge, and here's the plug that would normally go into there. I've removed that so the power supply doesn't have any load. We've got the normal mains input here, and it is currently live, so I'm just watching where I stick my fingers here. Okay, so the place where I'm testing with the scope, it's split exactly in half. Let's just have a look here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So the first 4 are ground, or 0 volts, or at least they should be, right? And the next 4 are the positive supply, and they're all bussed together. So anywhere on there will get me a reading on the oscilloscope and or the multimeter. On the multimeter, let's have a look and see what we get on AC, shall we? So, well, it looks fine, doesn't it? Virtually 0 AC. Bizarre. Let's have a look at what it looks like on DC. Bearing in mind that this is supposed to be a 12 volt DC output power supply, right? So, ah, 12 volt. 12.098, so 12.1 volts. That looks fine also. If it wasn't for reading off what we saw on the scope, we wouldn't know that there was actually any problem there. So let's pull this power supply out and look a little bit closer, shall we? Okay, so hopefully you'll be able to see this now. You can just about make out that these capacitors are bulged ever so slightly. These capacitors just here on the end, you can just about make out that the one closest to us is definitely bulged. Just gently tilt this up. So I don't know if you can see that. I can definitely see it with my eyes. And this large one here is also, that's fairly clear, you can make that one out. It's just bulged there at the end. So let's pull these capacitors out and get them replaced. Okay, so what I'm doing here is just sort of flushing the solder out. Oh dear. Well, that doesn't look good, does it? Let's get a little bit more light in here and I'll bring you a little bit closer if I can. Something tells me that probably wasn't making that good a connection, to be honest. Yeah. Yeah. I suspect that probably wasn't that lower resistance, to be honest. Okay, this one is okay, but we'll stick it on the ESR meter anyway, we'll have a look at that. This one, on the other hand, had enough. Yeah. Luckily, I've got this one just lying around, so they are the same value capacitors, so let's pull them off. Let's go. Okay, so I've just trial fitted the capacitors from the donor power supply, and I'm not proud of it. These are not physically the same size. They're the same value, but they're not physically the same size, so then it's not the best of fits, but I'm just going to roll with this and see what sort of an output we can get when we're finished. So let's get these things soldered in there, I think, before it changes its mind. Okay, now I can tie this afterwards. And then I'm sort of getting them well in there. Okay. They're pretty much in now. I'm going to go back in and tidy them up, and we'll get this refitted, and we'll see what happens on the oscilloscope. We'll see if we've done any good here. Okay, so that's the connections all cleaned up, tidied up there. I've put tons on either point. There's large exposed parts where they've not solder masked it, and I can only assume that's to get a good current transfer into the trace itself. And then back here, the individual traces, I've made sure that the blobs of solder are big enough that they shut all of the individual little traces together. Normally I wouldn't have such a large blob of solder on there, but it looks as though they're trying to do some current carrying capability with the extra solder traces there, so what the hell, we'll see what happens, right? Let's get it refitted. Okay, so I've got this thrown back together now, and it's a bit of a mixed bag of results actually. If I scope the output here, with or without the load, you can see we've still got that AC component on the output, which is a little bit disappointing. It's not as bad, but I wouldn't have expected anything to be there on the output of a power supply like this. I don't know whether or not it was simply acceptable to them because everything else is fitted with linear voltage regulators perhaps, I don't know. But I'm fairly well tempted to add another rectification stage after this power supply now. So we'll move on to the next part of the test. I'll quickly throw this together, just complete the build. We'll fire it up and we'll see if it's still making the silly noises, shall we? Okay, let's see what happens here. Yep. There we go. The silly noise is gone. Right, I'll just bring the microphone in a little bit closer and we'll have a listen. It's just what I've got here is a bit of coax with an electret microphone element, and it's just plugged into a USB sound card. So I'll mix that in with the audio. I'll just put this here, and I think in the background, as you can hear, no extra noise. So I'll call that a kind of a success, where I've put the lid back on and nobody died. So as far as I'm concerned, it's a winner. Okay, so my sister bought me some Sega Mega Drive games for Christmas. Bit of a blast from the past. I've had this console for a long time and it's a bit poorly, and I can't find the lead to plug it in. So I took this apart anyway to put a video feed on the back. So let's try this TV out and see what happens, shall we? Oh. Sega. I'll live with that. Yes! You never forget your level selects. Okay, I'm fairly well happy with this. It looks like it works, doesn't it? So I guess the next thing is I'll get on to doing the videos about the huge instrumentation score, and we'll get all those bits of kit sorted out. Okay, thanks a lot for watching, guys. Catch you soon.